Okay, everyone, welcome to the final lecture for this semester. Y'all have made it. Y'all have endured a lot, especially this being an asynchronous class. So let's go ahead and talk about what we're going to do today, and we can discuss the expectation for the next couple of weeks, okay? So most y'all should be working on your final project. If you don't, again, something I wanted to go ahead and address, there was some questions and everything else. If you're having problems downloading the matrix and everything, just email me. I'll send it to you as an attachment. If you have a group member that is not responding, then the expectation is that try to get as much of the project done as possible. But with that in mind, though, please be aware that they're going to go ahead and they're just not going to be a part of the actual end result. Because the fact that, again, this is a group project, and I'm a firm believer that if you do not contribute, then you do not get to share in the wealth of the grade that's earned. So that's my expectation, everything, and just going to let you know. I will be putting an announcement out as well about that. And again, I apologize. Apparently, I didn't realize that the video that was posted on for module 12 was the wrong one. So I'm fixing it with this video and everything. So let's talk about what we're gonna do this week. And then next week there is not gonna be anything due, but y'all gonna be finishing up. I may go ahead. I'm gonna do a poll real quick and see how y'all are doing on your project. If y'all want to go ahead and extend it. I was actually considering extending it to maybe the 3rd instead of the 30th. It'll give you a couple more days to go ahead and get things done. But other than that, just go ahead and let me go ahead and go through this thing, and we'll go from there. So this week we're doing chapter 24 and 25. You will have a quiz, okay? 24-25 quiz. There's actually discussion about SE Linux. I had it earlier, but I actually moved it to this week. There's a test verification, which we'll talk about that in just a second. And then let's talk about this right here. So in this one, because we're not having a lecture on the week 15, okay, there is nothing that you need to go ahead and do. There is a survey, though. And this survey right here is basically a survey so that I can go ahead and make this course a lot better. It's basically going to go ahead and there's a survey at the end of the course, right? And I implore y'all to please go ahead and do that, because that helps me guide me as an actual instructor. But the next thing is that this one's particularly about the course content. Like question number 2, was it too fast? Did you feel it was actually going pretty well? Was the content, did the videos help? Did these lecture videos, they help? Were the videos too long? What suggestion would you go ahead and make for that? Would you want me to break them up? Were the labs and projects very helpful? Did the labs did they help you go ahead and be able to successfully be completing of the project itself for that section? Was there any recommendation you can give me to make this course better? And lastly, for me, it's just about making sure that, I'm trying to do my best, because it's asynchronous, and making sure that it's almost as if you were in an actual classroom. So did I communicate well? Did I have any problems with that? Did you have any issues with that? So if you did, please let me know. I want to make sure that y'all are actually go ahead and getting the bang for your buck, even though this is asynchronous. So please let me know. And this is how I can actually improve the content better. And it's 10 points. So why throw away those 3 points, right? This weekend I'm going to be grading. So you can go ahead and know that I'm going to be getting a lot of things up and running and getting things ready to go. And again, that's going to go ahead and be that. The final exam will open up on the 6th, okay? It'll open up on the 6th at midnight, 12:01, and it'll close on the 10th. Let's get rid of that real quick. And it'll close on the 10th. So you'll have 4 days, 6, 7, 8, 9, actually 10, 5 days to get your final exam done. Just like the midterm, it's open book, open note. You don't have to worry about it. Do your best. You know, it's all multiple choice, 90 minutes, and it's 50 questions. So 2 points apiece, 90 minutes, and you know, just like the midterm. Okay, this will be comprehensive. So if you don't know what that means it could be over old content, it could be over new content, or it could be mostly new content. It's a generated listing, so just be aware of that. Okay. Open book, open note. Do your research. Get as many points as possible. You all deserve the points, okay? Right, that's the final exam. And then again, the final project and everything, I'm gonna go ahead and I'll take a poll and see if y'all need a couple more days to go ahead and get things done. I have it due on the 29th. But yeah, just that's it right here. And then the SE Linux discussion. Again, there's already a lot of y'all are getting it done. So this research in SE Linux, just by your own words, why you should go ahead and incite the source, why you should enable or disable SE Linux, and then provide an example how SE Linux can help mitigate attacks or meet compliance standards. We don't dive into a lot in this course, but SE Linux is a very powerful tool you can implement in your Linux operating system that can really do a lot of good, okay? So really focus in on that, right? Right, so I think that's everything. So let's go ahead and actually get with the lecture. I'll give you the final word of the week, and we'll go from there. So this last chapter, we're going to be talking about chapters 24 and 25, process control and system logging. These are some of my favorite things because I do a lot of log review in my job. So it's really cool to see how this works and everything. And I have my trusty, what do you call it? VM right here. So we can actually run through some of the commands and everything. So in 24, we're going to talk about processes and jobs. We'll talk about starting and stopping processes and jobs. We'll talk about how to list the processes out, how to change process priorities, and then display CPU and RAM. So the typical way is going to be the PS, okay? So we're going to do a PS command. These are all the processes that are currently running, okay? So PS lists all child processes. So you're going to have these two different terminology. You have a parent process and a child process. The parent process is actually what calls the child processes. So child processes are spawned from the parent. So you have the PID, which is going to be the process identifier. You have the TTY. This is the terminal window. And this is very important because this actually can tell you whether or not this is actually being run remotely or if it's run in the on the actual PC. What is the CPU time of the process? And then what's the command? PS and bash, okay? Now, we can do a PS TAC F, and that gives us full information. Let's do a PS TAC F. Now we get the UID, so that's a user identifier. We get the PID again, and this is where the parent process is, the PPID, the parent process identifier. C, that's going to the state. 1 means currently executing code, and 0 means it's already been executed. It's already happened. Okay, and then the S time is the start time. Okay, so we got that there. You can combine the PS and the grep command to actually look for a specific process. So we can do what this actually is called pgrep. That's pgrep for bash. There you go. And it's 3566. That's the PID number. So we can do, let's see, TAC L. We can do TAC G, capital G. Okay, so there's no group name by the group name. Let's see about TAC N. There you go, gives me the actual process itself. And then TAC U. Let's see, uname student. There you go. So that's actually the user that's actually started looking for grep. We're looking for the specific user, and then the actual process bash, and it says 3566. Okay, so we're good there. Another good command to use to look at running processes is going to be the top command. So think of it like the top 10. So this is the top printout right here. This is overall information at the very top. Overall info. This is the selected processes that are a list of processes that are being run, okay? You can use TAC D to change the interval where number is the number of seconds. So right now, by default, this updates every 2 seconds, okay? So we have top. You can see this has been up for 16 hours, 51 seconds, 54 seconds, and up for 34 minutes. It's got 1 user. The load average is 0.01. There's 196 total tasks being run. 2 of them are running right now. About 196 of them are sleeping. 0 of them have stopped. I'm using 1% of my CPU, 0% of my system, 0% of my NIC. 99% is idle. Okay, it's idle. And then 0% are waiting. This is how much memory I have in total. How much memory is free and how much is being used. How much swap I have total, how much is free and how much is being used, okay? We talked about swap a little bit earlier. So, again, so we got that right here. And again, we get the same thing. So we have the PID, the user. The PR is gonna be referred to as the priority. So it's the prioritization, okay? The next one is gonna go ahead and be the nice level, okay? The nice level. And they don't go into it in here. This is the virtual memory and how much is being shared, and then the percentage of CPU, okay? And we'll talk about nice levels in just a little bit, okay? So you can do a couple different other things. You can toggle colors. Let's see. Let's go ahead and do top, and let's do a capital Z. There we go. The toggles colors, capital Z again. Lowercase e removes it, capital Z adds it in. So let's go ahead and remove that. Change the default value from kilobytes to another value. We're not gonna do that. We can do an H for help. Here's all the commands I can do. Okay, bold, summary, locate, toggle, sort. Okay, we can kill a process. We can kill a process. We can do a K. PID to signal kill. So we can do a kill. Let's do ahead and say let's kill 3561. Let's see what that is. Yes. Okay. So we can get that there. Uptime. Uptime gives you some information about like how long this actual system's been up. It's been up for 16 hours and 3 minutes. It's got a 36-minute uptime. That's the load averages. This is very helpful when you're going, if you're triaging a box and trying to go and determine how long it's been up. So that's very helpful. Okay. The free command that deals with the memory. Again, we get that from the top as well. But you can see are you free? Jobs versus process. What is the difference between a job and a process? Any program running on a system is considered a process, okay? A job is a specific process executed from the command line, okay? So any process that is running, system process is a process. A job is initiated on the command line. So I run uptime, that is a job. So processes will start in the foreground and then they get bumped to the background, okay? So we can actually go ahead and do a process in the background, add an ampersand. So we've done that before. So let's go ahead and do uptime, okay? Let's add an let's go ahead and do top. Let's add an ampersand. So you can see right here that I have a job, it's stopped, and the service, actually, the command is top, okay? So let's go ahead and actually restart it. So I'm gonna go ahead and do a BG for background. So this is actually, this is in the background, right? I'm gonna do a background, and the process number is 1. I got that right here, 1. I'm gonna put a % in front. And still stop. it's still paused. So we can go still in the background because top needs to be in the foreground to work. So let's actually bring it to the foreground. Didn't like that. Let's actually, I did not like that at all. Okay, let's go ahead and do this. Let's do a sleep 999. And we'll put this in the background. Okay, let's do it. Look at jobs. It's running in the background, right? So let's go ahead and background 1. Notice it says it's already in the background. So that means it's already running in the background. If I want to go ahead and I can just look at jobs and let's do attack help. So let's look at man jobs. Let's see what we got here. It's a built-in command. Background for bind. List the name of all read line functions. Display. List the current read line. List current read line. Display read line. We can look at that. Key sequences. List all key sequences. All right. So nothing we want there. So we can actually bring to the foreground. Let's go ahead and actually bring to the foreground number 1. And notice sleep 99 is coming back to the foreground, okay? And that's because of the fact that we're now having it. Notice what's happened now is that it's locked up my my command line. So that means it's running in the foreground. If I want to kill it, I have to do Control-C, and that kills the actual process. And if I go back to jobs, notice the job is not there anymore, okay? Because I killed it. Okay, so we're going to talk about kill, pkill, kill all, xkill, and the closed box of a GUI-based program. I'm not going to go ahead and really talk about that because that seems very simple. But yes, so we can kill a process. Let's actually go ahead and do this. Let's go ahead and actually do sleep 9999. I'm going to put that in the background. I'm going to go ahead and do sleep 777 and put that in the background. And let's look at jobs. Oh. So I have 2 of them running in the background. I'm going to kill the second one. So I'm going to do kill %2. And look, it's terminated that right there. So then I'm going to do a PS tac FE. And I'm going to look for sleep. Okay. So notice we have this one right here. 4145. I have this one right here. And then I have the grep for sleep. Okay. So there's 2 of them. They're 4144, 4145. Okay. So we have that right there. And then what we're going to do now is we're going to go ahead and kill. We're looking at this one, 4144. Okay, it's not there anymore. 4145. Cool. So if I go back to jobs, all my jobs are gone. Okay. So there are many ways we can kill a process. We can do a kill tac L, and we can actually look for this. Just specify what you want. You can refer. There's a table in 24.tac6 which give you descriptions of each of these. I'm not going to go into that. There's also pkill to kill all processes assigned owned by the user, Sarah. So we can do a process kill by the user, Sarah. Okay, so or by the user. So here's the thing you need to understand. Sometimes what ends up happening too is there's going to be a point in time where you're going to experience where a parent process dies off. Okay, parent process dies off, and that parent process has actually go ahead and created all these little child processes. So then you have to run what's called a Reaper script. Yes, I know it sounds bad. And these child processes that lost their parent, we have a term for them. We call them orphans. I know it sounds horrible. It's going to get worse. So once these processes become orphaned and they don't have a parent process anymore, we have to run a Reaper script. And this Reaper script goes around and kills all the orphan processes. I know it sounds horrible, but this is what happens. And it's supposed to be comical in that sense, but yes, it sounds bad. you can do a pkill for a specific user. If you know, for example, that there's a process being run by, let's go ahead and actually open up Firefox, right? I'm gonna open up Firefox. Let's do a PS. Let's actually, let's do a PS again. Oh. All right, so let's do a pgrep for Firefox. 4247, okay? So let's actually find, so that's this process right here. If I was to go ahead and, so let's go ahead and actually do a ps-ef and let's grep for Firefox. So these are all the processes that are running from Firefox. And notice, so here's the parent process right here, okay? And this is the child process, 4360, 4378, 4397. And notice that you can identify the parent process because they all should have the same process ID, parent process ID. Except for this one. This one actually is going to be my grep, okay, my grep. So let's go and actually do a kill all for Firefox. So we're going to kill all the processes associated with Firefox. Kill all Firefox. Okay, now if I do a ps-ef or fe and grep Firefox, notice that all the processes are gone. But we don't have to do that as well. You know, that's one way you can do that. You can go into xkill, and this is a GUI utility, so you can do xkill. Oh, I can't spell. Did it pop up? No, I did not. Okay, let's see. Xkill. Oh, I got rid of that. So yeah, okay. So it looks like xkill is not going to work on this one. That's fine. So xkill is a GUI utility you can actually run. And what this does, you can click the process you want to stop. It's very much like the task manager in Windows. Okay. NoHup. So again, like I said before, each process has a parent process and they spawn children. Okay. When the parent process stops, and I was just talking about earlier, a hup signal is sent to all child processes to stop them. By default, a child process will stop when hup is received. Okay. So the hup actually, and let me actually, there's actually a definition for it. What does hup mean? I don't want hub, I want hup. Sorry. Hup. And next. Hang up, okay? So hang up process. Okay, you're on the phone. Hey, hang up. You don't need to, I need to go ahead and close you down. Okay, this call is ended. Hang up. Okay, so that's what the hup means. So we look at this and we're like, okay, cool. So once the prior process, you can actually go ahead and it kills it. So by default, child process will stop when the hup is received. To avoid this though, you can execute the child process with a no-hup command, okay? So you can do no-hup. So let's actually do that. Let's actually do no-hup. Hup Firefox. Okay. So let's actually go ahead and do a ps-fe. Oh, sorry, not pf, ps. And let's grep Firefox. So notice what happened. Up here, when we ran Firefox, notice it started all these child processes, right? Here, I'm just running the one process. I did no hup. Don't start anything else with Firefox. Just start Firefox, okay? So you can actually call a specific thing. You can see right here, this is Firefox browser, okay? Firefox browser, tab, tab, tab. So this is just starting Firefox itself. So now we're going to talk about process prioritization. We talked about this a little bit in the top command, The top has what's called nice prioritization. So a value range from -20 being the highest. I know it's kind of weird, but the negative is actually, the more negative you are, the higher priority you're given, and 19 being the lowest. Any job created by a user by default is given a nice priority to 0, okay? So you can set the prioritization, and what this does is it helps actually the operating system know when to go ahead and actually determine resource. Do you know when things are booting up and everything, or processes are booting up, they're vying for resources. And you want to go ahead and give prioritization to certain ones over the other ones. You can change prioritization using nice. So you can do, we have Firefox being started right now. So we can go ahead and let's go ahead and do, let's see, is Firefox still active? No, let's go ahead and /Firefox. Let's just type in Firefox. Okay. So let's go ahead and we're going to do a, did it keep it? Nope, it did not. Okay, so let me go ahead and come over here. I'm gonna start Firefox on my own. So I don't have to worry about that. Cool, we started there. Let's make sure it's running properly. And let's go to google.com. Okay, got it. Cool, yay, thank you very much. All right, now let's go ahead and actually do a PS TAC-FE. We're gonna grep for Firefox. Okay, here are all the processes running with Firefox. Now, I'm going to change the parent process. Let's actually look and see where this is. So 5587 is the parent process. Let's see where this is. 5587. I'm looking for 5587. There it is, right there. It almost went there. Let's do a, there it is. Nope, not there. Let's look at this real quick. All right, so let's go ahead and get started. So I went ahead and actually, I started off, like I said, I started off Firefox again. And what I went ahead and did is I went ahead and I'm grepping for Firefox. The parent process is 5587, okay? So now I want to locate this in my top command so that way I can go ahead and change it. So I can go ahead and do a couple different things. Let's go ahead and let's do a, let's look at the priority for Firefox first. So let's go ahead and do a top, TAC-P. I'm going to provide it with a PID. So there's my process. That's the parent process for Firefox, okay? Notice it's got a priority of 20 and the nice level is 0, okay? Because I started the process. By default, remember, the nice level is 0, okay? So I'm going to re-nice this process. Let's go ahead and explore this and see what happens here, okay? So I'm going to go ahead and do a nice TAC-N 5 Firefox. So now let's go do, let's repeat the same process. Okay, so the nice level is still 0. And that's one thing we have to kind of understand. So why is it the nice level didn't change? Well, it's because, let's see, maybe we need to go ahead and be a, sudo. Let's see. Okay, let's see here what's wrong. So yeah, so I'm sorry, it's my fault. So let's go ahead and do this. I have Firefox open right now. I'm gonna go ahead and turn this off. Okay. So remember it was 5587. So actually let's look for 5587 again. Okay. It's not there anymore because I killed it, right? So now we remember it was nice level of 0 is when Firefox started. Okay, that was nice level of 0. Now I'm going to do nice TAC-N. I'm going to give it a value of 5 now. And let's do it for Firefox. Okay, so you started that there. And actually, I'm going to put this in the background actually. I want to make sure that this is running properly. So it's 6696, okay? So now let's go ahead and actually, because, and the reason why is because if I run it with a nice level of 5, what's going to happen is that's going to go ahead and lock up my command line. And so I want to go ahead and make sure I can still do stuff. So let's go to a top. Let's actually do the same thing. Let's go ahead and do a, we're going to do a top. Let's actually do this. Let's see, we're looking for PS TAC FE, and we're going to do a grep for Firefox. And the new process is 6696, that's the parent process. So let's do a top 6696. Now, here's what's changed. Look at the nice level. It's 5. Now, here's one thing I want to point out. You as a regular user cannot assign a negative level. Remember, the negatives are higher priority. Positives are lower priority. So you can actually go ahead and set this. So if I want to do a negative, let's actually see what happens if I try to do a negative. So let's go ahead and actually, I'm going to go ahead and do the jobs. I'm going to kill 6696, right? Jobs. Okay, it's not there anymore. Let's check to make sure it's gone. Yep, it's gone. Okay, so let's go ahead and do a nice. We're going to do nice TAC N. We'll do a -5. Oop, permission denied. Okay. So it started, but I can't actually go ahead and change the nice level. So let's go ahead and actually, let's do this with the sudo. All right, there we go. All right, let's do jobs. Nope. Okay. So yeah, we're having a little bit of problem with this. It says protocol and everything else, but you get the idea that I cannot change nice level with negative unless I'm sudo. Okay. Renice. So let's actually do that. Let's go back to this one right here. Okay. Let's go here. I'm going to go ahead and I'm going to put up, we're going to do 19. 7444 is that process, okay? So I can change the nice level again. So let's go ahead and actually do a renice. TAC and let's make it 7. For TAC P, what's the process? Parent process is 7444. Permission denied. Why? Because you probably have to be root. Yeah. So now let's go ahead and look at that. Let's do a top. I'm going to do a grep. And we'll do grep for 7444. There you go. Notice that my nice level is 7. Okay. Now again, you can renice this. Let's actually renice this again. Let's renice this back to 19. So we went for old priority, new priority. And let's do that again. Nice level 19. There you go. All right, so that's it for chapter 24. Let's look at chapter 20. Oh, I do want to go ahead and do one command. There's actually another command that's going to be ps tac aux, and this gives you all the actual processes being run. Okay, all the processes being run. Right, just want to go ahead and throw that out there for y'all. Okay, let's talk about system logs and configuring syslog. So syslogs, they start off in the 1980s, and then they progressed to the NG, which is in the 1990s, and then now we're looking with rsyslog. That's dealing with rsync and stuff in the mid 2000s. All use the same format, rsyslog.com. So we can go ahead and guess where that's going to be, and we can go ahead and do an ls tac l, and we're going to grep for r. There it is. So we're gonna go ahead and let's go into rsyslog. There you go. There's nothing in there. So yeah, we would need to actually, it's probably either it's installed in the Active, so we have to go ahead and actually create the configuration file. So we can go to syslog or rsyslog.d, depending on which one we have. So we can go, let's see if syslog is here. Syslog is not here, so it's actually, that's why. So syslog is not here. So we are using our syslog. So we need to go ahead and configure, set this up. We need to go ahead and create a timestamp in the log file every X minutes, or we can actually go ahead and do a TACR to allow syslog to accept logs from remote systems. These are just some of the options we can use for our syslog. The configuration file is found here. By default, it's an Etsy default. So let's actually go there. Let's actually see. Actually, it's not going to be Ubuntu. It's going to be sysconfig. So let's go ahead and do Etsy/sysconfig. And there it is right there. So we can actually go ahead and just do a vim of our syslog. Yep. So here is the syslog. Specify syslog D options, okay? This is another config file we can do our syslog.conf specifies the entries that we actually can create. By default, no options are set. So you don't have to worry about that. We can add options in this to go ahead and actually help with us. And we can view these actually in the /var/log directory. So here's all the different logs that we can see. We see cron logs, we see btemp logs, we see Hawkeyes, kdumps, httpd. Okay. Notice that was actually updated on the 7th. So let's actually go into httpd just to, we can't go in there, so let's do a sudo. So there are the access logs, the error logs right there, okay? Kernel logs deal with the kernel. Mail logs are for the mail server. Cron D is for the cron jobs, which we talked about a little bit earlier on. And then this one, the syslog, has variety entries. So let's go ahead and actually, let's do a cat. Let's do a tail. Let's do a head actually. No, a tail. Let's do a tail. TAC and 20. Var. We're looking at syslog. See if it's actually, we don't have syslog here. Okay, so let's do offlog then. I have offlog. No, we don't have offlog. So then we'll do secure. And I can be root to do this. So you can see right here, this actually is the secure logs. This is where I'm running the commands, who's running the commands. So this is the configuration file. You can go ahead and that tells you where to send the log entries. And let's go and talk about that. So the word of the week is going to be syslog. Syslog, S-Y-S-L-O-G, syslog. Each sign in one rule with 2 parts, the selector. The selector has 2 parts, the facility. Gives you a little bit more examples in 454 and 455. And then rsyslog.conf, again, this is a newer features for rsyslog compared to syslog, is that it has modules. You can do global directives. They're stored in rsyslog.d rather than rsyslog.conf. So you have a separate file. We can actually, that way they don't actually mix and match. And if you make an edit to the configuration file, it doesn't affect the actual rules. So we can use the logger command. This actually creates a syslog daemon. And that actually does that. Log rotate helps. So go ahead and actually, you don't want to stack it up or anything, so that the partition holds the logs files do not fill up. So once it reaches a certain point, it rotates the logs. You can have it send it off to an offsite. You can go ahead and have it send it off to a USB. You can go ahead and delete them, which you probably shouldn't want to delete them. And you can configure that in logrotate.conf. Journal CTL. This also is a very modern system logging. This journal, you'll have it journal.d or journal D. So journal control or journal CTL is a very common one that we use. And the journald.conf file is what configures that. So that's 24 and 25. Y'all have made it through the end of this semester. Congratulations, y'all have done a really good job. Y'all, it's been a lot of work. I'm sure it's never been anything else. What I will go ahead and say is that, again, continue working on your projects. Get as much done as you can. I want to see, even if you have no compliance from other group mates, try and complete all of it. And I'll be posting that actual announcement to extend the actual completion of these projects to the 3rd, so that I can grade them on the 4th. And that way you'll know what you have going into the final exam. With that said, I hope you enjoyed everything. Please make sure you fill out the end of course survey. It helps me understand myself as a teacher, whether or not it was helpful, whether or not I need to improve better, whether there's some things I can go ahead and work on. And other than that, y'all have a really great time. And again, if you missed it, the word of the week is syslog, SYSLOG. Y'all have a great rest of the semester.